Hey, welcome back to the channel. Good to see you again. Hope you're all well. Thanks for joining. Today on the bench I have the Harman Kardon SR600. Now I promised I would get back to this and I put it off for a while. I've been itching to do this one for a long time now, ever since I bought it. I purchased this one on eBay, got it for a good price because everybody else must have been asleep at that time when it was going for bids. But here it is. It's filthy. You can see it should be brushed aluminum, but it's kind of all brown. The knobs are filthy. It's actually missing a knob, one of the tone knobs here, but nothing you can do about that. So this is an interesting receiver because this is the first series of receivers that Harman Kardon started making when they stepped into the new age of semiconductors. Previous to all this, they were building tube units, and I think this one, don't quote me on this, but it was in production from 1964 to 67 or 68 or something like that. So yes, it was just in that time when everybody stopped using tubes and they were retooling their engineering, they were retooling their factories to produce solid state units. And they made sure that everybody knew, because they right on the front here, solid state, and that was the wave of the future. So this is the 600. Now Harman Kardon made 4 receivers in this series. They made the SR300, SR400, which I'm not really sure what the difference is between the two, maybe features or power output. They made an SR600, this one here, and then they made an SR900, which was their top-of-the-line flagship receiver for that day. This one's a 600, and I'm having a lot of troubles finding any documentation on it whatsoever. I found a schematic for the 900, which will probably be useful because they probably shared a lot of the same electronics inside, the same schematic, same structure. And yeah, this is unique. So let's have a good look at this. Okay, hopefully you can see this good. We have a chunk power switch here on the left hand side, and it's orange amber, so I'm assuming it's illuminated from behind. Doesn't feel like it's latching though. Maybe it is. I have a full function switch here with some interesting stuff on it. We have auxiliary, which is stereo auxiliary inputs on the back. FM mono stereomatic. Now I do believe this has a stereo decoder in it because we have a stereo light. So that would be your stereo FM, mono FM. We have a phono function, and I'm assuming that's a magnetic cartridge phono input. We have tape head stereo and tape head mono, 2 selections of those. Now the difference between phono and tape head inputs, they're both the same level inputs. They're very low level, like 2 millivolts, 5 millivolts signal. The difference between the two is phono will have the RIAA equalization, whereas your tape input won't. It'll be a straight in shot to the amplifiers with no equalization. So when you're playing back your tape from the tape deck, you would connect this directly up to the tape head and bypass, well, from what we're used to in modern tape decks, they have their own amplifiers built in now, but this is back in the time when they didn't. So you have a low-level tape input, and you could select between mono and stereo depending on your gear. Single volume knob. And then we have, for A channel, we have treble and bass controls. Okay. And then we have here a range of switches. We have contour, in and out. Contour is your loudness button. Tape monitor, we have 1 tape loop. Low cut filter, that's your rumble filter for your phono. High cut filter, it's for scratchy records or hissy FM. This is a nice feature here. You can, the choice of removing the tone controls from the circuit or having them in. So you can listen to it flat, and then you have a stereo mono switch. Up top you got a tuning meter, a nice little cute little tuning meter, and you have a lamp for FM stereo, and then you have your FM dial scale. Now you're going to notice this doesn't have AM, no AM tuner in it. I think that was something that was back in the 60s. I don't think they took AM seriously as a hi-fi medium. Like they just wanted to have FM and phonos and tapes. On this side we got a tuning knob. It's got a nice feel to it, but it's dry. B channel treble and bass controls. Usually you have the bass on the left and the treble on the right. I don't know why they decided to do that backwards. Put your low frequencies first before your highs. We have a balance control here and a speaker selector. So this is speakers off if you want to listen to phones, headphones. Speaker system 1, speakers system 1 plus 2, and just speaker system 2 alone. And we have a stereo 1/4 inch headphone jack. Alright, on the back we have our speaker outputs. And that's kind of a unique system. We got speaker system 1, 4, 8, 16 ohms. Speaker system 2, 4, 8, and 16 ohms. Okay, so the left hand side is speaker system 1, the right hand side speaker system 2. We got channel A, plus and minus, channel B, plus and minus, and then for the same for the other channel. Got FM antenna input, 300 ohms, no 75 ohms back at this day. We have our 4 output devices for 2 for each channel, and I suspect these are germanium power outputs. If I think I'm right on that one, I'm not sure. And then there's a speaker fuse for each channel, and this one's missing the channel B speaker fuse. This one here is intact. It looks like it's intact. Okay. Now I think somebody's been servicing this thing. This doesn't want to go in. There we go. Somebody's been doing some scribing on the back here. This is channel B, and then they're questioning this transistor, writing in pencil. So I don't even know if there's transistors in there. They might have been removed. 2 courtesy outlets, switched, both of them switched, and we have a line fuse for the amplifier itself, power input, and then we have all our inputs for our functions. So we got this one's here for tape head, phono low, phono high, auxiliary input, and then your tape monitor. Across the top, your outputs and your inputs. And then the ground screw for 3-deuce hum. I don't know if you notice here, but there's no ventilation at all on this thing. There's no holes drilled. It's all solid panels. This back panel here, this piece here is a slab of aluminum, and it's about, I don't know, 1/8 of an inch thick, and that's going to be our heatsink for the back devices, and that's all it relies on is just this aluminum back panel. So let's have a look inside. Alright, so the lid does have some scratches here, like they had some kind of piece of equipment sitting on top that gouged it pretty good. Some heavy scratches. 4 screws. Lid comes off, and there it is. It looks like the bottom, but that is actually the top. It looks like it's put in upside down. Now you got to remember, this is back in the days when they were just used to building tube amplifiers, and this is typical for tube amplifier construction. You have a chassis, a flat plane. You'd have all your tubes mounted on it. All your components would be underneath. All your capacitors, resistors, whatnot would be underneath. And on the other side, you'd have your tubes, your IF transformers, your everything else that's capacitors that are mounted. So this one looks unmolested completely. You can see a lot of stuff going on here. All these old electrolytics, 100 microfarad, 35 volts. There's a couple transistors here. 2 transistors there, 2 transistors, 2 transistors here. Look at these big chunky diodes. These are germanium diodes, I'm assuming. That's kind of interesting. It has a nice vintage smell to it too. very clean. And that's because we have no ventilation holes drilled. Here's our power supply. We got 2 big caps. We got rectifiers. So we're going to have to go through and check all this out. Interesting. I don't know if this works or not. I haven't powered it up yet. With the one fuse missing, I was kind of concerned. I wanted to have a look at it first. There's some trim pots here that are wrapped in petrified tape. These are probably the bias adjustments, maybe. Here's a 500 microfarad cap at 15 volts. I wonder if that one's bad. Another one. Yeah, all these old electrolytics will have to go. Oh, we got a whole bunch of them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Little ones, 11, 12, 13, 14, 15, 16. Yeah, there's a whole bunch of little ones. I might have to place an order for these axial caps. I know I have some here, but I don't think I have that many. Transistors, got one here. These are sockets, I believe. Transistor sockets. And the transistors will be on the other side. But here they have transistors soldered right to the terminal strips. Here's another transistor. Very interesting. Okay, let's flip it over and pull off the bottom. Okay, the bottom cover is kind of caved in here. It looks like maybe somebody put some weight on this and bent it. But 4 screws on the sides and up it comes. Oh, we got some kind of leakage here. Not sure what that is all about. Maybe somebody was spraying stuff in. Who knows? And there is a good look at the chassis. What is this? Little perf boards with, it looks like a little baud circuit they put in there. Here's those 4 transistors, 5 transistors from the, they're sitting in sockets. And pull these out. They're 4-pin devices, so I bet you they have a shield. Okay, electrolytics, capacitor, power transformer, a tiny one, so I'm not expecting huge power out of this thing. And we have 2 output transformers, or these are interstage transformers, I'm not sure. Great big function switch, 4 gang, 5 gang switch here. It's all spread out, lots of room to work on it. Even got transistors in here too, look at that. Interesting. FM tuning capacitor and all the IF. And these are, I think, these might be the tone amplifiers, I'm not sure. There's a lot of this, I don't know anything about it. So looking here, these have got 4 sockets for the output devices, and I see there is transistors in each one. So they're all there. I'm just going to do a quick check and make sure we don't have shorts on any of these output devices. And then I'll see if I can populate that fuse. This thing's definitely going to need a full recap though, because all these caps are, well, approaching 60 years old now. So let's see here, let's do this. Okay, where is, I'm assuming these are PNP devices. That one's possibly shorted. That one too, but it could be just the circuit I'm reading. Oh, that one's definitely shorted. Oh, somebody's been soldering on this one. Doesn't look very good. Yeah, I think this channel might be. But that was the one that wasn't marked. And it's still got an intact fuse. If I take that fuse out. No, doesn't make a difference. Okay. I think we only got one good channel here. I'm not sure. Now I'm assuming these output devices are germanium. Probably what I'm going to do is pull these off and test them out of circuit. Because if you just don't want to do any more damage than what it has already done. I don't think I've powered this up. I think I might have plugged it in and turned it on, but that's about as far as I went. So let's pull these devices out and then we'll have a look at them. Now I do see a problem already, and this doesn't look very pleasing to me. Look at this transformer on the right. Looks like it dumped its smoke everywhere. And I think, let's try removing it just to lift it up and have a look. If that's the case, if we have a bum transformer, we might have a real trouble getting this thing running again. Have a look here. It's quite possible that this transformer is done. You can see it definitely got hot. I don't know. I'm going to have to check. Looks like we have two windings here and one winding here. Yeah, definitely let the smoke out, that's for sure. Okay, I'll put that back temporary for now. And we'll revisit this. All right. So I got these. These should be PNP. That's good. And that looks good. 221. Yeah, hard to say. Let's see what the other ones look like. More of the same. Not the same. A little bit of difference here. These are all originals. Original Harman Kardon part numbers on them. That one's shorted. And that's shorted. So we definitely have a trouble here in this channel. The one that has the smoked transformer. That one's bad. I should mark that. Okay. Nope, no good. Yeah, no good. Okay. All right, we got a challenge ahead of us. Now, two blown shorted transistors. Suspect transformer is probably open because it's cooked. Yeah. So we've got one working channel. Alright, here's a look at the SR900 schematic. This is not for this model, but I assume it's pretty much identical. So they have minus 23.5 plus 23.5 volt power rails. And this center line here is your output to your speaker switch. It's fused 2.5 amp. And then they have this interstage transformer. Primary is driven by these two transistors, and the secondary is driven by these two. These are probably out of phase, 180 degrees. And I think one of these windings on the secondary are burned out. I don't know, I'm going to check it with an ohm meter. And then we had our two shorted transistors. So it's fairly basic circuit. It just, it's prone to blowing up, I guess. And this is the early days of semiconductors. Transistors were all new to these engineers, and this is how they developed the amplifier. They were kind of still in that tube mindset where they had interstage transformers, and yeah, so not much to say about this. Looks pretty basic. It's got what is this? Tone control in and out. This is our tone circuit here, and we can switch it in and out. There's a transistor here. I think this does a little extra amplification because you're going to have losses here in the tone circuit. And then we have two stages of amplification. Goes to the primary, and then from the primary we have two secondaries. Each secondary drives its own transistor. Okay, so let's have a look at this transformer and see what we got. We got orange, white, green and yellow are our secondaries. Red and blue is our primary. So, okay, I see some more damage here. There's a resistor here. I think it's a 3.3, or maybe that's a 0.33 ohm resistor. Just crispy ash now. Yeah. Yep, nothing left of that resistor. Okay, so let's check these transformer windings. We got orange and white. Orange and white. And we got 3.6 ohms there. And the other winding is green and yellow. Green and yellow. And we got 3.7 ohms there. I think we got lucky. And then the primary is red and blue, which goes down under to the top of the chassis. So I think we might be okay. It looks like we just have a crispy. This is a emitter resistor, 0.33. Here they got 0.27s on the schematic. Let me see. 0.27, 2 watt, but these aren't 2 watts. $27, 1 watt, 33 ohms, 2 watt, 330 actually, and 0.27, 2 watt. Where are these 0.27s? Okay, these are 0.5 see, this schematic's not going to match. These are 0.5 ohms at 5 watt. I wonder if they're good. Let's see. It may be burned out too. Yeah, we got 5 kilo ohms there. That one's open. This one's intact. This is a 390 ohms, 2 watt, 7.2. It's going beyond, it must be out of tolerance. There's a short here somewhere. Yeah, there's a short somewhere. There's supposed to be some diodes in this circuit too. This one has diodes, but I don't see any diodes in this circuit. I'm still suspicious of this transformer though. It might have shorted turns. If it's been cooked that bad, it could be damaged beyond use. So we might have to take that transformer out and test it. All right, here's a look at the power supply section for the SR600. Again, this is not for my receiver. We got primary circuits here. We got two switched outlets and a 3 amp fuse. This fuse is open on my receiver, so it's blown. And then we have two secondaries. One secondary looks like it's a leftover transformer from the tube era. It's got filament winding, but this is driving a number of bulbs, number 1847 bulbs, 6.3 volts or whatever they are. And then from this they derive a crude half-wave rectified power supply, 8 volts. It's probably supplying something here. I don't know what it is. And the main power supply, we have a bridge rectifier. We have plus 23.5 volts and minus 23.5 volts. Okay, and from the positive supply, well, actually on both supplies, they have these pi networks. These multiple capacitor pi network things. We got 3000 microfarad here, 3000 microfarad here. And then we have plus 30 supply. This is odd. They're taking the AC off the secondary and they're putting it through a capacitor. This is a 200 microfarad, 20 volts, and then they're rectifying it. I think they're trying to get like a crude voltage doubler here, and they're supplying a 40 volts, 25 volts, and a 30 volts from this little supply here. And then the plus minus 23 volts, that goes to the power amplifiers. Now I found that I have a short on these two diodes. These two diodes are reading 0 ohms, and they're short circuited. So whatever happened to this amplifier, it took out these two diodes as well. It seemed pretty catastrophic. There's a lot of damage happened here, and yeah, so we're going to get sorted. Let's start with the power supply and get this power supply back in working order. There's a 10 volt supply here. There's a Zener diode, and that's regulating this 10 volt supply. I don't know what they're using that for. But they have a number of different supplies. They got plus 8, plus 40, plus 25, plus 30, plus 10, and then your rails for the power amplifiers. There's a plus 22 here. So they got voltages going all over the place. Okay, so like I said, this fuse is blown. This is the power input fuse from the line cord. These black twisted pair, that goes to the power switch. I tested the power switch. The power switch is working fine. It's working as intended. So that's all good. We have blown fuse. Now over here in the power supply is 4 diodes. I don't know why they're 2 different sets of diodes. This is this purple wire here. This is our positive B plus. It's a different kind of purple. This is another kind of purple, is our negative. And if I check these diodes here, these metal can ones, can you see that? No, you can't. Okay, let's do this better. These diodes aren't shorted. You can see the cap they're charging, and the same for this one. Now if I go here and check these two, actually it goes this way. This one's a dead short, and that one's a dead short. Let's just snip these two out. Let's snip this one out. Snip this one. Check this one again. It shows it is shorted. So what I'll do is I'll replace these two diodes. Get something in there that's more robust than these wimpy little things. Yeah, they're both shorted. I'll replace these two diodes, and then we're going to have a good look at these caps too. It's supposed to be 3000 microfarad. This diode is not shorted. Is that the only one? The only one that I can see. Okay. So far I've been checking some of these caps. These ones here and here. They're holding up actually not too bad. They're out of tolerance quite a bit. This one measures like 128. And actually has a low ESR. This one measures 550. It's supposed to be a 500. Oh, it's a 200. It measured 200 and something. But they measure high because they're high leakage. But they're still holding up. Alright, been struggling with this for a while now. And what turned into a simple diode replacement is becoming a little more than that. So, what I did is I replaced these two diodes. These are 6 amp, 1000 volt. More than adequate. These ones tested fine. This is the bridge rectifier. I should have just ripped it all out and put it in a bridge rectifier, but I want to try and keep original look. So this capacitor here is a 3000 microfarad. Okay. This capacitor here is a 3000, 200, 200. So they were using this capacitor as a filter for the negative supply, this one for the positive. And these have been disconnected now. There is no longer a connection to them. Now I replaced the negative filter cap with a 4700 at 50 volt, and you can see it's tied here to this negative. This would be the negative rail. This is the cap, and then I have a wire, the orange wire, going around to the ground. This is a star ground here. Everything's tied to. This is the center tap of the transformer. This is all the other grounds. That's fine for the negative. Now for the positive, we don't really have much room to work here. And plus I have another circuit here I need to remove off this capacitor. I have, from the positive rail, I have a 120 ohm resistor, which is now broken. And it goes to a 200 microfarad, and then it goes to this brown wire that's buried here. You can't see it. That goes over way up to another circuit. What I'm going to do is I'm going to move everything over here, because I wanted to put a terminal strip in here, but there's just no room. And I see there's a terminal strip here with 2 empty lugs and a ground that aren't being used. So I'm going to run a wire from here through 120 ohms to this cap, and then this cap gets grounded. And then I'll run that brown wire. I'll remove that brown wire and run a new brown wire to this lug here. Okay. And then there's this diode that it was grounded on that lug. And then I have a 15K resistor and two red and a green wire. They all terminated on this 200 microfarad capacitor lug. And I'm going to move everything over to this one on this side. And the diode can go here, and everything will actually look pretty natural. That's what I'm trying to get, the natural look. I don't want to have it look like it's heavily modified. One thing you got to be careful of, this black and white wire here, that's the 120 volt mains power coming in from the other side where the switch is. The power comes in here, terminates on this terminal strip, and then goes into the transformer. So you got to be careful of what you put around here. You want to keep this area clear because this is mains voltage. So I'll make sure I get the wires out of the way. This cap here will probably lay in something like this. Probably lay right down here. If I have enough room. Once I get this diode and resistor out of the way, it'll free it up, and then I can ground this, and then that'll be power supply done. 4 new capacitors to replace these 2 cans. This can here, I haven't done anything with. I don't even know. This one is a 400 microfarad, 1000 microfarad, and 200 microfarad. So it's got 3 caps in here as well. I'm probably going to end up replacing these. This This can here is supposed to be 3,000 microfarad. It tested out down below 2,000. And the other one, I bet you it's low too. I didn't even test it, I don't think. I'm just gonna, let me see if I can get a ground here somewhere. Get this out of the way. Get a ground here, and let's check the value of this one. Yeah, see, this one's really far off too. This one's checking out at 4,400 microfarad, and it's supposed to be 3,000. So it's got heavy leakage, and it's not legitimate. This one here is supposed to be 200, and it checks at 157. This one's supposed to be 200, and it checks at 190. Yeah, so we'll get those out of there. So that's an update for the power supply, and then when I'm done I'll get back to you and I'll show you what it looks like. It's going to look pretty much like this. Okay, so here it is. Got it all reworked. The two new rectifiers installed. Now, hindsight, I think I'm going to replace these old ones as well, because you know, they're old technology. They're 60-year-old technology, and they might have been stressed when this whole thing grenaded itself. I have the two 4,700 microfarad capacitors mounted. They're up against the chassis. They're silicone down. They're not going to flop around. Those have been replaced. So these will take the replacement of the bulk filter capacitors. And the little circuit that was in here, I moved over here, and I put the two filter caps, 220 microfarad, 35 volts. And this diode here, I originally put it in a silicon rectifier diode, but then I thought about it, and this circuit looked odd to me. So I checked this diode, and it's actually a 10 volt Zener. So I put this back in the circuit, the original diode, and that's all correct now. And everything else is original. I haven't done anything else here other than move a resistor, added a wire, removed a wire, and reconnected from here to here. So that's pretty much it. Now everything's done for the power supply. The power supply should work normal now. We have our positive B plus, negative B plus on these two thick wires, okay, and they go up to the other side of the chassis. Haven't done anything with this part of the power supply. I'm just kind of, my goal is just to power this up and see if it works. I have a feeling it will work, because I'm kind of spot checking capacitors and values of resistors, and everything seems okay. So I have a feeling this is going to turn on and work. So that's what my goal is, to power it up and see how it works before I actually do anything as far as restoration wise. Now we got some problems on the other side I want to show you. Okay, now to the power amplifiers. These two transistors here on this power amplifier are tested okay, and everything here looks okay. I haven't ohmed out any of these resistors yet, but everything seems fine here on this side. The problems start here. This is our positive. It comes in and it's tagged to this, and then this 3.3 ohm resistor is completely ashed, and that goes to the yellow wire, which goes to the secondary of this transformer, and then back to the green wire. Okay, this transistor here and this transistor here were completely shorted. This resistor here is open. This is a 0.5 ohm 5 watt. This one's fine, this one's fine, this one's fine. So everything happened here. I didn't realize this till I was starting looking at it this morning. This purple wire here comes down and connects to this collector of this transistor. And also on the collector of this transistor is a wire that goes out to the speaker fuse. So somebody took the power wire, the B minus, and moved it from here to here on this collector. It should actually be on this collector, because this white wire feeds power to the other amplifier. So I got to remove this, move it over here, and connect it up again. So that was a major catastrophic failure. If somebody moved that wire and then powered it up, you're actually dumping minus 25 volts or whatever onto the speaker, right? Okay, so that's fine. We discovered that. We're going to move that back. I'm going to replace this resistor and this resistor. And I have, believe it or not, I do have some new old stock of some ECG 121s. I got a couple of them here. And I am going to try using these transistors. I think this one's used, but it still tests fine, and this one's brand new. Okay, so we're going to try and get this amplifier working again. It's pretty basic. There's really nothing to go wrong with it aside from the germanium. Let me blow this down here a bit. This whole circuit here is self-contained and isolated from everything else. It's fed from plus 23, minus 23, and you know, I could even power this up and test it without the transistors in place. I do not have these diodes in on my circuit here, so I don't know if I should add these or if I should leave them out for now and just test without. I have a feeling they form a purpose. Actually, this one here is between the 27 ohm and 0.27, and this one is the same. So I guess under certain conditions they don't want this voltage to go over 0.6 volts. It clamps this voltage here across these resistors under certain conditions. So I might benefit me to put these in. I don't know if I'll ever see that. I could scope it and see what kind of shenanigans is going on here when under load and stuff. But my first goal is to get this thing working, and it looks as simple as replacing those two burned out resistors and those two transistors, and this thing should work, assuming my power, the signal transformer is not burned out, and it did ohm out, so it looks fine from an ohm meter point of view, but I don't know if it's actually working, so it might have shorted turns. So my next goal is here to get some transistors in here, get some resistors, and maybe I could power this thing up. Okay, I went through and I replaced two resistors here, the 3.3 ohm and the 0.5 ohm, and I just want to check the circuits here. I actually pulled these transistors out, these two, and tested them. One of them was shorted, so out of all four transistors, only one of them was good. But that's okay, because I had 3 germanium sitting in my parts drawer, and I'm kind of matched them up. And so I have 2 working sets of germanium transistors. So I always want to, before I put transistors in and power it up, I want to make sure everything's 100% here. So what I'm going to do is I'm just going to apply power. This is just 12 volts, and I'm going to apply it to the supply here. So if I can connect one on this collector right here. That's the positive. I need the negative. This is the negative, and then the positive can go right here, and that's feeding at 12 volts, 12.5 volts, and I'm consuming 50 milliamps on the power supply. Now, the only thing that should be consuming current is these 4 large resistors here, and I just want to check and make sure. So if I check across these resistors here, this one here, can you see the meter? Yeah, you should be able to. If I check this one, I got 6.3 volts here, and 6.04 volts there. Okay, that's expected because they share the current's going through both of them, so they share the current. These ones here, see, I got 12.2 volts here on this one, and this one I got 1/10 of a volt. That doesn't make sense. So this one is shorted. Is it possible to have a carbon resistor shorted inside? It looks fine. I don't see anything wrong with it. It's not cracked, it's not burnt. That's weird. Let me shut the power off. And check my ohm meter here. This one tests out, it's supposed to be 390 ohms. It goes up to 200 and something. Okay, this one here shows 7 ohms. That's odd. I'm going to pull this resistor out and test it because it shouldn't be 7 ohms, it should be 390. And maybe this is the root cause of why this whole thing grenaded itself. Okay, so it appears I found the problem. I have a short between this green wire and this orange wire. These are secondaries, are supposed to be separate, as shown on the diagram here. Orange and white are one winding, green and yellow are another, and there's a short between the two of them. So maybe that's what killed this amplifier. I'm not sure, but this transformer is going to have to come out, and let's see if we can do anything for it. I'm not hopeful, but you can always try, right? So let's take it out. Alright, let's get into this. Hopefully it's not something bad. You can see this nastiness here, all this stuff that got cooked out of it. Ooh, hit me in the eye. There's some here too. This is old tape, it looks like. So we got our 4 wires here, which is promising. Let's before we do anything, let's confirm our fault. I think I measured between orange and green. Okay, so this is one pair of, this is one secondary, and it should yeah, 4.9 ohms. Okay, that's good. This is our other secondary, 4.9 ohms. So those windings are good, but I have a short between green and, yeah, orange, I think. No, green and white. No, yellow and orange, maybe. Okay, there's our short between yellow and orange. It's on this side. Okay, let's get rid of this. Let's see what we can do for this thing. What is going on here? Looks like the short might be down in here. It doesn't look like it's here, that's for sure. What are these 2 wires? I don't think there's anything under here worth talking about. Okay, there's our orange wire. Alright. So the short's not there under the tape. Okay. You can see the wire here. cross each other? Is that what happened? I really can't see much in here. It's all gooped up with the they seem to be going together at the same spot. That's probably where the short is, right here. The insulation failed when it got hot. And that's right at the very beginning of the windings. I'd have to unwind this whole thing and start over. It's something I might have to do. Let's see here. Yeah. And those two wires, they go, it's almost like they cross each other right here. Maybe that's where it is. If I can dig around it and find if it's all paper. Okay. I see something shiny in there. I think I might have cut something. Oh, there's the windings. Wow. Still. Oh boy. Okay, so there's a, I can't do much with this. I think what's going on here is these two wires, one's green, one's amber. I think they're twisted together. And I think that's where it's shorted. So my only solution for this right now is to rewind it. Now it shouldn't be that hard. It's not a big transformer. It's only got 3 windings. But what I want to do first is I want to take some measurements of the primary and secondary and get the phasing right so that I don't screw this up. And the matter of, it's probably so cooked in here, when I start unwinding it I'll see that it won't be usable. And the only way to fix this is new copper in this thing. So that's what I'm going to do now. Shouldn't be too bad. I think it's going to be all right once I get take the E-core apart. That's pretty easy. And once that's apart, I can start unwrapping it layer by layer and counting turns and keep notes on how which way it's wrapped and where the wires come out the bottom or the top or whatever. And then we'll just reconstruct this little core transformer here. It's pretty sad. So I did look online, and that part number that Harman Kardon gives us, this one here, this H10520603, doesn't show up anywhere on anything. So it's pretty obscure. Alright, that's the road I'm going to take. I'm going to rip this apart. I'm not going to show it. I'm just going to put my head down and get to it. And hopefully it won't be too hard. Yeah, it's just a interstage transformer. There's nothing really critical about this. I'll find some new wire and we'll get it back together again. Okay, once you remove the E-core and then the outer wrappings, you start to see the real identity of this transformer. For example, I have 4 wires sticking out this side. These are all the secondaries. I got 1 wire here and 1 wire here. This is my primary, but they have a splice here and here in the primary. I don't know what they're doing there. So they have different different layers will be secondary, different layers will be primary. Here's another 2 splices. These are on secondaries, so I'm assuming one secondary has a splice and the other one has another splice. Actually, I should measure this right now. Maybe it's not shorted anymore, but I still think it is. But got this outer layer all cleaned off, and it's just a matter of start unwrapping. Here's my finished wrap, and I could actually count these. I could count the turns with a magnifying lens and record it, and before I unwrap it. It only looks like there's maybe about 15 or 20 layers on this thing, so it shouldn't be too bad. And once I get down past the, I'll see how bad it is. You know, maybe if these wires are cooked, I might have to find new wire. I don't think I can reuse this wire. It's probably not safe to reuse since it's been overheated and insulation has been compromised. So I'll get started on this right now. Okay, this thing's a cooked mess. Even if it wasn't shorted, I don't think it's usable because the insulation on this these windings is completely burnt off. And look at the paper, how it's turned black. Look at this. It's just comes off in little flakes, and it's all pieces and crumbs. So yeah, I'm starting to figure out how this thing's wound. Probably have about 3 layers of primary with a really fine gauge wire. And then, what was it? 1, 2, 3, 4, 5 layers of secondary windings. The secondaries are wound together, 2 wires parallel. And the secondaries are wound, 5 layers of that. And then another layer of primary. 2 windings of secondary, a primary layer, 2 windings of secondary, and then a primary on top. And what am I at here? 8 layers, and I'm halfway through. So 19 layers. That's what I kind of figured. And it's not too bad, actually. It's about, some of them have 70 winds per layer. Some have 25, depending on the wire thickness, right? So this won't be hard to reproduce. And I'll have to find out some source for my wire. All right, so I got all the windings off my cardboard form. This is where I'm going to start with. This is going to be this is the original cardboard that came with the transformer. And this is what the E-core is going to fit back onto. So all my windings are going to go on here. Now it's not just as simple as pulling off the old windings, putting new ones on, because you've got a lot to consider. You have to consider the number of turns, because the number of turns between primary and secondary determines the ratio and how much gain the voltage gain or current gain the transformer has, depending on that ratio. And the wire size is also important because it has a certain resistance, right? The certain length of wire at a certain gauge has a X amount of ohms, and if you change the diameter of the wire, the resistance is going to change as well. So what do? I don't know what gauge I'm working with here, but part of the problem I have is I don't have a lot of coils or transformers to rob wire from. I have a few of these small power transformers, line operated power transformers. Like this one looks like it might work. And another thing is you got to make sure you got enough wire to do the winding from start to finish without any interruptions. And I should be okay. So what I found is this is a doorbell transformer from a house, or for a house. And I checked. This is the primary. And this wire diameter is the same size as the primary of the transformer I'm trying to wind. So I'm going to use this here. This diameter wire is too thick. This is 14 thousandths or something I measured. Let me see, let me measure this again. Yeah, 14 and a half, 14. That's too thick. So I can't use the red winding. I can use the amber winding. So I'll disassemble this core. I have to grind out these welds and disassemble the core, and then I'll get at the windings itself. And I found another one here. This one here has 2 secondaries, and these measure out at 10 thousandths and I need about a 10.5, but that's pretty damn close. So I'm going to use this secondary of this one, and it has 2 windings. I hope there's enough wire here to do both of them. Shouldn't be a problem though, because there are, let's see here, there's 1, 2, 3, 4 secondary windings on the transformer I'm winding, and they'll get soldered together to create 2 windings. So I'm going to use this. I'm going to take this core part. I already started taking the core apart, and I'll use these 2 transformers as donors, and the rest of this is a scrap. The rest of this can go back into my stash. Okay, so it's a day later. Spent the whole day doing this. Got a new transformer wound. So yeah, it's not the prettiest thing, but it'll work. Now I screwed up here. I wanted these wires to come out on this side, and for whatever reason, I don't know, maybe I didn't start my coil properly, but it ended up on the same side. No big deal. It's just a matter of splicing it to wires. So this can go back in. First I want to compare. See, I don't know if I have the phasing right on these wires, these secondaries. So I'm going to compare it to the original one that's already installed. And I'm going to see if the phasing is correct. If not, I'll adjust it with when I wire it in. And then this can go back in, and then we can start testing. I'll clean up this skid mark here that this thing left, and we'll clean that all up, give it nice shiny looking. And then we'll try putting it together again. Maybe we can get this thing running today. Okay, transformer's wired in, so I should be able to connect my 12 volts up again and check the circuit, see if it's balanced or not. So which was positive again? I think it was this one. And negative was this one. Okay, actually drawing less power than I was before. I was drawing 600 milliwatts. Now it's down to 380, 31 milliamps. So that's probably what it should be. Let's check this out. Can't see the meter. Okay. So across this resistor should be 6 volts. And this one should be 6 volts. Now this one here, 6.25, perfect. Excellent. I think we're ready to drop in transistors and give it a try. I think before we put any transistors in, we should actually power this up and test the power supply first. Not that I expect anything to go wrong. Okay, so I replaced the 3 amp fuse that was blown, and it's shut off right now, and it's plugged in. And I have a power meter here. I don't know if you're going to be able to get this in frame. I'll show it. And then just going to turn this on, see how it blows up. Drawing 25 watts. 24. And going down. It's actually consuming. Okay, we're getting some smoking here. It's from my 1.8. This resistor's smoking. Let's try it again. Let's see what we have here. It should be positive. Wrong. Okay, here we go again. This should be positive 24.5. Negative. This should be a 10 volt supply. 10. And this here, smoking resistor, is not happy. It's got 24 volts on it. it's shorting out here, that's why. Okay, we'll diagnose this after. But we know we got a working power supply here. We've got our rails. And nothing else has gone boom, so that's good. Down to 18.9. I think that resistor's gone open now. Yeah, it's cooled off. That's fine, we'll replace that too. Alright, so I went to troubleshoot this short circuit I have on the plus 22 volt line. And it's actually, what happened was this resistor is resting up against the ground lug. And the paint was the only thing that was insulating the two. And the paint broke down, and that's where it causes a short. So I did pull up the schematic and checked what the plus 22 volt feeds. And it feeds a bunch of bias voltages here in the late stages of the FM tuner. And like I said, 120K, 120K, 220K, 10K. There's all these resistors here that are limiting the current. So a short couldn't happen on any one of these. And that made sense because it happened right here, right at the resistor. So I get that sorted. Another thing I did is I put transistors in for the left channel, I believe. Let's flip this over and have a look. I put these two transistors in, and we're going to test this side. Basically what I want to do is I'm going to feed in 12 volts again on the rails, and we're going to see how the current is distributed between the devices and how the voltages are. If everything looks good, we're going to do the same for the other channel. So I'm just going to feed in 12 volts again on the negative and the positive. And I got my current limiting on the power supply cranked way up, so we're not going to see anything yet until I turn up the current. And I just want to make sure we don't have any weird overloads or... Okay, so if I turn this up, we've got 12 volts on the circuit now, and we're only drawing 30 milliamps, which is normal. I think that was the same as without the transistors in place, so they're probably not conducting yet. So let's try this one more time. Get 6.24. 6, okay. So those transistors are turned off right now and they're not doing anything. So let's put the other ones in and let's see how that channel looks. Okay, I got the other two devices installed. Let's power it up with 12 volts and we'll see how it settles out here. So I'm turning power on and I'm drawing 35 milliamps now, slightly more. So those transistors are, one of these transistors is conducting, I think. Let's see here. Let's try between here and here, see what we got. We only got 5 volts here now. And on this side, we have 7.3. So we have a difference now. And if I go from ground to the speaker output, we're going to have an offset of 1.9 volts. Yeah, that's what I was afraid of. So I think that one of these transistors is damaged, to be honest. Let's, oh boy. Let's power it up under its own power and see how badly it behaves. If it goes up in smoke, it does, then we'll have to do something different for those transistors. But there's no adjusting that because it all depends on the transistor gain. I think when I tested these, one of these had a really high gain, and it's probably really out of place in here in this circuit. So let's try this. Let's see how bad the offset it really is on the speaker output before we connect any load. So plugging it in, can you see that? Yeah, I think so. Okay. Let me see if I can hold this with one hand. Okay, turning it on. Yeah, that didn't sound good. I popped a resistor here, I think. Yeah, I was drawing excess current. Okay, let's see what we got. This resistor is now open, I think. Yep. No, it's right here. Okay, that's open. And plug this thing before. Okay. Emitter collector. Seems like we have a short now. Yep. Emitter base. Emitter base collector. Got a short on all three devices. Okay, so let's try this one. Emitter collector. Shorted. Shorted. Now we got a junction there. Maybe this transistor's still good, but I think this one's gone. Let me pull them out. So both these transistors have collector emitter shorts now. And I find it odd. There's no shorts between the base and any other ones, but collector emitter shorted. So, what do I do now? I'm fresh out of germanium devices. I think we're going to have to try a silicon device in here now. Let's see how that goes. Yeah, this is not... I didn't expect this to work, but I wanted to give it a try anyways. I noticed when I tested one of these, I can't remember which one, it tested really high gain. It was possibly leaky too. Maybe that's the reason why it was leaky and it turned on and it self-destructed both devices. But this channel here is working okay. I haven't put any signal through it yet, but it seems to be behaving. This one here is still giving me troubles. So I went through my TO3 stash, and surprisingly enough, I found a couple more germanium transistors, original RCA devices, and they both test fine. So I'm going to put these in, and first of all, I got to replace this emitter resistor. It's blown open. It's 0.5 ohm, so I'll get that done. Put the transistors in, and then we'll power it up and see how this one goes. It should be okay now. Pretty sure that I had a bum transistor in there from the start. We wouldn't balance up, so that's what it is. Okay, so I got the new transistors in. I got the new emitter resistor installed, and I got it powered up right now with 12.5 volts. And I'm drawing 33 milliamps for both amplifiers, which looks really promising here. This is what it should be like. So I should be 6 volts across each transistor, which is normal. Let's look at this side. 601, 633. A little bit of an imbalance there, but I have a feeling this is going to power right up. So let's power this up. How are we going to do this? I just don't want to smoke those transistors one more time. I'm going to power it up through my variac slowly. Just need to monitor some current somewhere. I'm just wondering where I can do that. I guess I can monitor it across one of the emitter resistors, and We'll see if any of this stuff gets hot. Alright, so what I did is I added two 100 ohm resistors on the output, speaker output. This is going to just provide me with a light load. I don't want to get crazy currents here, so we're just putting a light load on there. And we're going to power this thing up through my bench power supply. We're going to slowly ramp it up, and we're going to see what kind of currents it's consuming, because we're just trying to prevent another blow up of the transistors. That's what we want. These transistors are not cheap and they're not available, so we don't want that to kill another pair. So let's see here. I got the power supply hooked up. Let's right here. Let's turn it on. And we're putting up 0 volts right now. Okay, let's turn this up. Let's turn it up to about 20 volts. And I'm adding the power to the positive negative rails. Okay, 20 volts, we got 56 milliamps. So let's do some calculations here. So if these two transistors are turned off, all the current flow will go from here through this point, through this resistor, through this resistor, through this resistor, through this resistor. So these ones say 330, but in actuality I got 390 ohms, so that's double that up, and that's what, 780. So if we do Ohm's law, I equals E over R. Let's see here. So if we have 20 volts here and across here, and the current's going through here, let's calculate the current for 780 ohms. I equals E, which should be 20, divided by 780 ohms, and that should give me 25 milliamps. And you can see here, I'm driving 2 amplifiers, so 25 milliamps is pretty close. We're at 56. So that would be, what, 28 milliamps each, which is not bad. So those transistors should be pretty much turned off. So this is what I'm reading across one of the resistors, 10.4. Let's go to the other one above it. And this is the left channel. And I got nothing here. What's going on? My meter is locked up. What did I screw up? Max. I don't want max. Okay. So 9.5, 10.3. Okay, that's a little imbalance. Let's go to the other channel. The channel that keeps blowing up. So we got 9.5 on that one. And go up a little higher to the top of the resistor. And it should be 10.3. Okay. Let's take this up. We could go up to 50 volts on this power supply, and that would simulate full line voltage on the transformer. So let's turn this up to 30 volts. Current's climbing quite a bit. 30 volts, and we got 94 milliamps. All right, we're at 30 volts. Let's take it up to 40 volts. Volts is right here somewhere. So I should only have about 50 milliamps on each of these. But I got 156. So that's about, let me do the calculations here. Alright, so what I did is I powered it up to about 50 volts, and it didn't grenade itself, which is a good sign. We still have an imbalance here on this channel. Now I'm thinking these resistors here, these are carbon comps, these are 390 ohms, and they measure up around 420. these are, well, these are gold bands, so they shouldn't be that far out. Let's see what gold bands should be. Yeah, they shouldn't be any more than 410, and these two are actually outside of that tolerance. I'm going to check these ones as well. These ones have been stressed though, and yeah, these are out. These are out. Maybe that's the reason why I have such an imbalance on the current draw on these two transistors. This one's conducting, and from what I can tell, it's conducting quite a bit more than this one. So I think if I balance this out, it'll come back down. I've also replaced one of these 3.3 ohms resistors and left the other one intact. And I have a feeling that one's probably gone too. All these carbon comp resistors are this age are garbage, especially if they get stressed. Let's see, this one doesn't even measure anything. Wrong scale. Yeah, it measures 3.8, which is probably pretty close. So I'm going to replace these two, and we're going to bring it back up again on power, and we're going to see if it balances out better. All right, so I replaced all four of these resistors. Three of them were out of tolerance, and surprisingly the fourth one was actually bang on, but I chose to replace it anyway. So that, when I did the right channel here, it improved quite a bit. Let's have a look here. I'm going to start feeding it voltage again. So let's turn this up to, let's take it up to 40 volts. And already you can see the current consumption has gone down a little. 40 volts, I got 164 milliamps. Okay, so let's check DC offset on the outside of the speakers here. So here I got 3.2. I got 1 volt and climbing. Why is it climbing? That's odd. Let's try this. $22.2, 17. You still have a big difference. This side was better though. 18.6. 20.7. Yeah, this side's more balanced now, but this side is definitely off. Okay, I think we're going to power it up, see what it does, if it blows up or not. Let's do it again. Alright, so we're going to go live here. Let's see. I have this thing up front. Can you see that? So I have 1000 hertz tone. Let's turn this on. I'm feeding into auxiliary. Volume is up maybe a bit. Everything's set. Speaker 1. Let's try this out. Yeah, it's not happy. Wow. Not happy. Let's see what's going on here. One channel's making noise, the other isn't. Okay, so what I did is I reversed the polarity of the primary of the transformer that I rewound, because I don't know if that was the problem. I think I had that backwards, and it was actually providing a positive feedback instead of a negative feedback. So I reversed those 2 wires, and let's plug it in and try it again. Hopefully we didn't damage anything when we were doing that. Let's try this. And we have our tone. Let's see what current is here. We got power consumption. Seems like I only got 1 channel. We're still under 30 watts. Even on mono, I still have nothing. Seems okay, it's not overheating. We just got a dead channel. Tape head.
That's fine.
Tuner is very actually, let's try and sort out why we only have 1 channel. Let me try directly to the collector. There we go. They're both channels now. Right, left. I'm wired backwards, but whatever. Fuse is dodgy. So there you have it. We got both channels working, both amplifiers. Let's see if we can get an FM station on this.
JJAutoworks.ca. Want even more spiritual guidance, conversation, and learning? You'll love Shine On Demand. That's where you'll find great.
I think I'm hearing stereo. This thing still needs so much more work.
It's free, informative, and insightful. Catch every moment of some amazing shows. Check out Shine On Demand at shinefm.com.
Buying home doesn't have to be difficult. Here's next.
ਵਿੱਚ 18 ਸਾਲ ਤੋਂ ਘੱਟ ਦੇ ਬੱਚੇ ਹਨ ਤਾਂ ਤੁਸੀਂ 6 ਮਹੀਨਿਆਂ ਵਿੱਚ 600
mono, maybe that's why I'm not picking up stereo. Let's try this again. There's definitely stereo there. lot of distortion. But no light. That's what I was hoping for. I guess our light is burned out. Okay, it's working. Awesome. So let's do. Let's connect up the scope and see how the amplifiers are doing with the difference between the two transformers and the unmatched transistors. Let's just hook it up and see how it... Okay, so I got it all wired in for 8 ohm load. I got it connected directly to the collectors because I think there's something going on either with the speaker switch or the speaker fuses. I'm not sure. I'm not getting continuity all the way through. So I shut that off, bypassed all that, put it directly to the amplifier. Everything should be good to go. Here I got 1000 hertz tone going in. Let's plug this in. And we can watch this as well. Now, let's turn this thing on if it's all ready. 28 watts. And silent. Why is it silent? Because we don't have anything on there. Okay. Not getting anything on the scope at all. It's because I'm playing with the balance control here. And the volume's actually over here. So let's turn it up. Oh, that one channel's really dirty. Yeah, the top one's clipping already. It doesn't look very healthy. That one is the one channel that was repaired, so it's not doing too well. Nothing's overheating. We're just hitting clipping sooner. Okay, clipping is right about here. We got 7.59 volts RMS on the output. Okay, let's try the other channel. I think the other channel is doing better. Let me switch this over. Okay. Right there is clipping. Back it off a bit. Probably right about there. And I got 10.66 volts RMS output. Now that could be an adjustment too. I'm not sure. There is adjustments on the driver board. Let's take this up to a different frequency. Let's see about 10 kilohertz. Let's see what 10 kilohertz does. It has a real hard time with 10 kilohertz. Let's take it down to 5. Total power consumption before clipping is around 80, 87, 89, 90 watts, somewhere around there. Let's holding out. It's getting a little warm. It is what it is, I think. It's working. Okay, I think that's where I'm going to stop this video here today. Did a lot of work to this. My main goal was trying to get this thing to make noise under its own power, and I did that. I got the amplifiers sorted, kind of, but it does sound a lot better than nothing before. And yeah, it's we got a lot of work to do. So there's going to be a part 2 in this one, and I think I've already just done some spot checking on some of these caps, and some of these caps are dead. Surprising the tuner even came alive, but it did. I had faith it would make the noise into the tuner, and it did. So yeah, it's interesting journey, this one. So like I said, I'm going to stop this here. I'm going to pause this. It might not be next week. It might be for a while because I got some clients' equipment to repair. So it might be a while before I get back to it. But so far, for a first step, I think we did pretty good. All right, so take care. We'll see you on the next one, and talk to you later.